Hello and good morning and welcome to volume number 6 of my Microsoft Hololens 2.0 educational series. Now in volume 2 and volume 2.5, we thoroughly reviewed the research mode and all the sensor streams for this particular device in regards to computer vision. But what I want to do today is now show you how to take all of these different inputs. Essentially, there should be 6 different camera types or sensors, left front, left, right front, right, a depth A-hat, which is articulated hand tracking, depth long throw, and then you have the inertial measurement unit for the accelerometer, the gyroscope, and the magnetometer. So we want to record all of these individual streams, and then we want to convert them. So if we have hand tracking, eye tracking, head tracking, gaze tracking, and we can use these type of long throw and depth camera volumetric recording series to create all kinds of different types of scenarios for computer vision researchers and scientists. So now let's jump into just showing you what that initial recorder stop-start, and then we'll go into a very in-depth, thorough analysis and review of how to set all of this up. Let's get started. Welcome back. This is the stream recorder, and what this is going to do is capture all of these computer vision streams from the visible light camera, also from the Azure V4 depth camera, which operates in 2 different modes, and we'll discuss that in depth as we get into the next portion of this. But what this is doing is showing the current height as in regards to where it sees the floor, and then the surface mapping is active. I don't have any QR codes, but once I press this start button, it's going to go ahead and record all of this long throw eyes gaze data, and also the head tracking data, and it's going to record all of this information, including the depth and the long throw camera. And as soon as I press stop, all right, now we've got all that recorded, and we're going to jump into the next portion of this to show you how to get all this set up, and then how to extrapolate all of this information and how it took all these different images and recorded all these different sensor streams in real time. Let's get started. Hello and welcome back, and let's get started. So you saw how we initiated and instantiated these sensor streams in the first part of the video, and then we started the recording for all of the different sensor streams for the research mode. And now that we're going to go through and how to set this up, which is not that complicated, but the instructions you have to follow step by step to ensure that you don't miss any steps, which is I've done this several times now and I feel very comfortable with it. So number 1, if you follow volume 2 and volume 2.5, I step you through on how to successfully set up the research mode and developer mode on the HoloLens 2, so you can configure the research mode sensor streams to record appropriately. And what we need to do inherently at first is review these systems in detail, which I did not do in volume 2 and volume 2.5. So we have an RGB camera, 4 visible light cameras, 2 on each side, stereo and periphery. We have an inertial measurement unit with accelerometer, gyroscope, and magnetometer. And then we have the depth camera, the Azure V4 with the long throw and A-hat mode. Now I haven't gone through some of these sensor streams for the resolution and format, but for the visible light cameras, the resolution's about 640 by 488 bit, long throw depth at 320 by 288, 16-bit, long throw AB. It should be around 320 by 288. Again, AB is active brightness. It's computed from the same modulated infrared signal for depth computation, and these images are illuminated by the infrared, and they're unaffected by the ambient visible light. So the A-hat and A-hat AB, that's the articulated hand tracking from the Azure V4. Now the A-hat is a high frame rate, 45 frames per second. It's near depth sensing. It's used for all hand tracking. Again, it uses that AI inference model via machine learning, and the hands are supported up to 1 meter from the device. Now the HoloLens 2 saves the power by only calculating Elias depth from the phase base time of flight camera, TOF. Now this means that the signal contained only a fractional part of the distance from the device when it's expressed in meters, okay? And then the long throw, low frame rates, 1 to 5 frames per second. Now this is going to be involved in the volumetric capture for far depth sensing and used to compute spatial mapping on device. Now there's 2 modes of that IR stream, which I already discussed, and then the IMU sensor streams are going out and capturing. For the IMU, it's used to determine linear acceleration along the X, Y, and Z axes, as well as gravitational forces. Gyroscope is used by the system to determine rotations, and the magnetometer is used by the system for absolute orientation estimation. Now, each of these research mode interfaces are going to retrieve frames and associated information, resolution, and time steps, and then they're going to map the sensors with respect to the device, WRT, respect to the world. This is just a very brief synopsis of what I'm discussing here in regards to all these different research mode camera sensors. But again, I didn't review these in volume 2 and volume 2.5, and I thought it was very important to kind of briefly touch on this now. Now again, when you set all this up, you're going to download the research streams, and then you're going to upload the SLN to Visual Studio 2.9 and build that out. Now it's very important to understand when you build it out in Visual Studio, the app main.c file will have at the top 2 different research mode type sensors. You can either select depth long throw, you can select PV RGB or eye tracking, and for each individual research mode application sensor stream that you want to record, you're going to have to build and deploy a different application. So let's say you just wanted to do eye tracking, that'd be one application. If you want to do long throw and depth, that'll be a separate application. You have to build that out appropriately, okay? So now that we have all that set up and configured correctly, and we've already briefly reviewed the left front, left, right, depth A hat, depth long throw, IMU accelerometer, IMU gyroscope, and the IMU magnetometer. Now all these 6 types of different sensors and the remaining 3 are IMU, and the camera and IMU sensors differ in the methods they expose. For instance, camera sensors expose methods for projecting 3D points in camera space to 2D points in image space, while the IMU sensors do not. So it's really important to look at all the different intrinsic and extrinsic information coming back from these data streams. And as we record them, what you do is when you press that first green button, what you're going to actually see here at the top is it's going to record all that information to one subfolder. So you'll have all this information at the top here in the File Explorer. You'll go into the File Explorer user folder, local app data, and then you'll go into this application for the recorder, and each one of those will have a CSV file, a TXT file, the long throw tar file, again, the LUT for 2D and 3D, and with respect to the world. Now, it's important to understand that each one of these are being coordinated back to something called the rig node. Now, each of these sensors returns the transform to the rig node. This is the device origin. This is expressed as extrinsic rigid body transforms or rotation and translation. On the HoloLens 2, the device origin corresponds to the left front visible light camera. Therefore, the transformation returned by the sensor corresponds to the identity transformation. Again, this is very important because this is your base transform coordinate system right on this side. And you're always converting the coordinate frames back to this specific spot. So you can see above me on this side, these are the individual recordings that I have for each one of these systems right above me. And then way over here on that side, you see all the different files that we've recorded. So again, you can select each one of these individual systems, and then you can download them. So you can go into the device portal to download manually, or you can use something in here that they actually have. It's called the Recorder Console. And you have to put in, you can use Anaconda, and I'll go ahead and show that right up here, the entire file format and the command that you have to do in Anaconda. You'll navigate to this Python file folder, and that will actually compute and process all of these images so you can output them to various different formats. And you can also use it again as a computer vision system. That's why I'm so excited about this, because researchers and scientists and interested enthusiasts for computer vision can utilize this technology to advance their understanding of volumetric scanning and mapping, simultaneous localization and mapping. There's all kinds of things. I think they even have a TSDF integrator for SLAM, so you can create essentially a big map in real time. I'll go ahead and show an image of that right here so you guys can see what that looks like. And then some of the tracking for hand tracking and eye gaze and the volumetric capture for long throw. We'll go ahead and throw that right over here so you can see what that looks like. This actually comes from the Microsoft research for the Computer Vision 2020. Thank you guys so much for posting all this research. I'll put all of the files in the comments and below. So thank you so much for paying attention to this, and thank you all for continuously publishing your open research for Microsoft out of Zurich. The professor over there and your entire team for mixed reality is amazing. I can't tell you how much I appreciate you guys continually sharing information with me, so then I can put it all together and then share it with so many people out in the world that are interested in spatial computing, but also maybe in their students and high school students and at the university, and they can kind of see and get a feel of what the next transformative inflection points for these types of spatial computing iterations are already here. The future is already here. It just is not evenly distributed. So thank you so much for paying attention to this volume 6 today. I really appreciate you always tuning in. Please subscribe to my channel below, and you have a wonderful weekend.